Welcome to the channel. So the time has finally come to start tearing down this lathe. This is the Dean Smith & Greaves Z13 Minor, made in Keighley, England in the 40s. So I want to kick things off at the back side of the lathe with the tailstock, and after removing this giant 30mm bolt that holds the bed clamp on, we can just go ahead and pull it straight off. This is a bit of a closer look at that clamp that actually rides along the underneath of the bed. So now that we've got it off of the lathe and onto the bench, we can begin to do a little bit of work on it. And I'll start by taking the hand wheel off at the back, which is almost 18cm in diameter. And of course, as soon as I pull it off, the bloody key falls out, although I do manage to find it alright. So this whole unit weighs around 35 kilos, and it's got a rough footprint of about 20 centimetres square. And already we can see a little bit of the hand craftsmanship. For some reason they've decided to drill this out instead of mill it out. And this also caught me off guard as well. I kept turning it and realised it had just been pushed in there. This nut that I'm removing here is the other side to the quill locking mechanism. So as you turn the handle, it tightens up into this nut and clamps onto the bottom of the quill using these little rounded lugs. And with that removed, we can slide the quill straight out to the front. And I believe this tailstock, or at least this quill, has got an MT3 taper, a Morse 3 taper. So the threads on this lead screw are about 150mm, so I'd say there's a good 140mm drilling capacity on it, and this is the brass nut at the back. And yeah, I wouldn't say that's looking too great. I can already hear the back. And that's the sound of quite possibly 80 years of use. This little piece that I just tapped out is the quill guide, and it goes into the quill and slides up and down the length of it, and it stops it from rotating inside of the tailstock when you're doing an operation like drilling. This is one of two adjustment bolts, and just before I remove the base plate though, I'm going to remove the bed clamp lever. Round on the back side, we've got the second alignment screw, and after that's been taken out, we can separate the base off. And it definitely looks like there's been some moisture in there at some point, and then we can take the last piece to this bed lock out. So just quickly, there was something that I forgot to mention in the last video, and that was the fact that I pulled this lathe out of a garden. And that's kind of the reason that I'm doing this video and sort of tearing it all down. So when I originally went to see this lathe, it was under a tarp in his garden under a tree. And when we took the tarp off, the entire chip tray at the bottom was completely full of water. And the guy who had it just wanted to get rid of it. He did say that if he couldn't sell it, it was just going to scrap it. And he did also tell me that it had been sat in his garden for almost 2 years as well. So onto the tool post next then, and this is a square indexing tool post that can hold up to 4 tools, and on the bottom of the handle here you can see the ratcheting mechanism that allows it to index up to 4 times for the 4 different tools, and we'll see how all that works in just a minute. As you turn the handle on the tool post, it pushes round this little collar that in turn pushes down this little key that allows you to index the tool post by 1/4. So you can see this is how all these pieces sit inside of each other when they're in the top of the tool post. Now that centre collar has only got 3 notches in it, and that's because it's got to have enough time to push that pin out of the way before you can actually start to index the tool post. If it had 4 notches in it, then it would try to push the pin out of the way at the same time as you indexing the tool post, and obviously that wouldn't work. So these are all the pieces from the tool post, but just before I move on, I want to have a look inside of this handle. And it does give you a little insight just how simple some of this stuff can actually be. It's just a single grub screw to retain 2 little spring pins. So onto the top slide next then on this lathe, and this is where your tool post normally sits. And you can see this one's fairly marked up, there's quite a lot of little dints in there. And that's caused by chips being squashed in between the bottom of the tool post and the top slide over a period of years. These 3 Allen key bolts on top tighten into the gib and actually hold it in place, while these 3 on the side actually adjust the gib and take out all the slop or movement in the top slide. After that we can remove the hand wheel and then remove the little dial ring on the outside and the little brass pin that locks it. And when you tighten this screw up, it pushes the brass pin into the bottom of the dial ring and stops it from turning. So now that we've removed all the bolts, we can slip the gib right out the back. So this large grub screw that I'm removing here retains this kind of backing plate that the hand wheel sits up against. I think I've seen it called a dial shield before, and then this smaller one is just an oil port. On the back side we've got another Allen key bolt that holds the brass nut in place, and then we can go ahead and tap this shield off that the lead screw runs through and then remove the lead screw. So this is the little brass nut in there, and I can tell you it's in much better condition than the tailstock, and the little brass shims that make it up to the perfect height. Now these ways on the back of this top slide are in pretty good condition. I'm not seeing any visible wear lines or anything that looks terribly bad that jumps out at me straight away. Now I've not gone over with a dial indicator and checked these properly, I'm just sort of visually inspecting it and going over with my hands. But at some point we will go over all these parts with a dial indicator and just see how far out they are. Onto the cross slide next then, which is a little bit like the top slide but just much bigger. We'll start by removing the 3 retaining bolts for the gib and then we'll slide it straight out the back. And while I'm around the back of here, I'm going to remove the nut from the end of the lead screw as well. And then from there, it's pretty much the same process as the top slide. We can remove the handle and pick the key up off the floor, remove this little Allen key bolt that retains this backing plate that the little lead screw goes through, and then we can remove one more Allen key bolt that holds the brass nut in place, and then remove the lead screw. It probably would make more sense to undo the lead screw first, and then undo the brass nut, but for some reason I did it this way around. After that's been removed, we can pull the cross slide straight off the top to reveal the ways, and there does seem to be a little bit more damage on the cross slide compared to the top. Well, I suppose technically this is the saddle, but there seems to be a little bit of a groove where it looks like there's a chip been stuck and it's been rubbing up and down about a quarter of the way. So to remove the saddle, I'll start by removing the saddle plates on the back side, and these plates are split up into 2, one of which you can adjust to get the perfect tightness. And these plates just stop any type of upward rock or movement, and from what I've seen they also help with chatter a little bit as well. This handle that I'm removing here actually extends out through the back of the lathe, and it's what you use to activate the clutch with. The bar that runs through it also runs through the apron, and it gives you a second handle, so even if you're working at the bottom end of the lathe, you've still got a handle to activate the clutch with, and that's about as far as the health and safety goes on this old DSG. So this other long bar just above it is your feed rod, and this also goes through the apron and it connects to the gearbox at the back of the lathe, and this is what drives all the gears inside of your apron to give you your main power feed but also your cross feed as well. The next one we're going to have a look at is the lead screw, and this is what gives your lathe thread cutting abilities along with an assortment of change gears at the back. Unfortunately though, because my lathe is right up against the bench and I don't have a lot of room, I'm unable to pull the lead screw out through the tailstock side of the lathe as you would do normally, so instead I'm going to have to pull it out through the headstock side, which is not ideal. I'll also have to do a bit of fiddling around with the apron, because both feed rod and clutch bar run through it, and both of which should ideally be slidden out through the back side of the lathe. So with a little bit of help from Smallside, this lead screw actually pulled straight out the back of the headstock, no problems at all. I just wasn't anticipating it to be so long. I even had to lower the knee on the bridge port, and after that I was still hitting the back of the casting. It stands about 2 meters tall, or exactly 197 centimeters. So with that removed, and these other ones just pulled away from the gearbox, we've got one more thing to work on before we can separate the apron from the saddle, and that is this end support. While it's still on the lathe, I'm going to remove a few of these handles off of the front, and it's just going to lighten the load and make it a little bit easier to work with and sort of manoeuvre once we've got it up onto the bench. All these handles are going to get removed at some point or another anyway. So from what I can see, we've got 4 6mm bolts that are for the saddle plates on this side, and they're also split up into 2, one for the left, one for the right. And then we've got 4 bigger 8mm bolts that hold the saddle to the actual apron itself, including this very rusty one that's most likely not been removed since the lathe's been built. Since I'm here on my own, I'll just use 2 pieces of wood underneath the apron and then slowly unwind the bolts and let it fall onto it. There's only about 10mm for it to go. These are the two smaller saddle plates for this side, and these are what the 6mm bolts went into on the top. And by the looks of this little rusty patch in the top corner, there's not been much oil flow through this in a while, but there does seem to be a thin film of oil all over these gears, and it's more like a grease. So this is the saddle in its current condition, and there was meant to be bed covers and not bed wipers on this model of lathe. You can see the ends are a little bit beat up, but more importantly there's a big score line that runs up one side of this saddle. And initially I thought that was probably some sort of oil way for oil to get trapped, until I looked on the bed of the lathe and realised that there's a corresponding score line. So I think a chip's come through this hole and it's just been stuck in between the bed and the saddle, just basically rubbing away. Now there is meant to be a small little grub screw in that hole, but someone's forgot to put that back in. Going back over to the apron then, we're finally able to pull out both of these bars, and they both stand about 143 centimetres. So this larger gear is what moves up and down to engage with your main power feed and then your cross feed as well. And then the handle at the bottom is what actually engages it with the power rod that comes from the gearbox. And then on the back side we've got the half nut, and this actually engages with the lead screw that moves the saddle up and down at the perfect speed so you can cut threads. So after removing this first grub screw, we can tap out this gear, and this is what your hand wheel attaches to on the front. And this actually drives another gear inside of the apron, which then in turn runs along the rack on the underneath of the bed. This is the cam mechanism in there that sits inside of that gear, that actually rocks it forwards and backwards, and then you've got this spring actuated pin that keeps it all locked into place. So it's this gear that actually runs up against this gear, which is the same one that your hand wheel drives, that runs up against the bed rack. And when the gear is rocked up into its second position, it runs up against this one that's attached to the end of the lead screw on the crossfeed. On the back side is where a lot of the magic happens in my opinion. You can just see the top of that brass gear sat inside of that cast housing, and that whole unit actually rocks forwards and backwards through the use of this lever, so it can engage with the rest of the gears inside of the apron. And when you actuate this lever, it pulls back this collar just enough for it to get in and out of this metal catch. So after we've removed all the grub screws, we can slip out these little collars, and there's one on both sides, and they're kind of like centralising collars, and it's what this whole cast piece uses to actually swing around. You know, when you engage and disengage the feed, that's what this rocks around. And the reason there's not a bar that runs through the centre of this is because there's actually a little worm gear in the bottom of there that runs up against this brass gear, which then actually drives all the gears inside of the apron. So this portion here is actually where all the power from the power rod goes into your apron. Coming round to the half nut next then, and these ones actually appear to be cast, as opposed to being made out of brass, which is what you'd normally see. So on the inside then we get a little bit of a glimpse to how this all actually works, and you can see that there's sort of two offset lobes in there that move opposite from each other. So as you engage and disengage the half nut, these lobes sort of turn inside of these cutouts and move the teeth either away from each other or towards each other. So the last thing to remove on this apron is the thread dial, and this actually runs directly up against the lead screw, and it tells you exactly when you need to engage the half nut. It just really makes sure that your carriage and your part are synced up together. So just before we move on, you can see that when this apron was being cast, there was most likely a few defects in it, and instead of just chucking it out and making a new one, they've decided to go over with a bit of filler rod and salvage it, which I actually think is pretty cool, that someone took the time to fix it instead of just lobbing it. So after removing a few covers on the back then, we can work our way around to the feeds gearbox. And I'm going to remove all the oil, and there is a little bit of a drain port on the bottom of this gearbox, but it wasn't working, so I had to just dump it all out the viewport. Then after that, I'm going to remove this drive gear that connects the gearbox to the rest of the lathe. While I've still got it here, I'm going to remove a few of these screws on the front, and from what I can tell, they sort of go through the casting and hold some of the shafts in place. And with that done, we can loosen the four main bolts that actually attach this thing to the side. I don't really have an instruction manual for this thing, so we're just going to kind of start anywhere. This is the forward and reverse selector, and this is what actually changes the direction of the feed rod. So on the back side then, there's a few more grub screws to remove, and these just kind of keep some of the bushings in place. You can see this one's kind of like a flat-headed dog-pointed grub screw. And then on the inside there's even more grub screws that just essentially lock all the gears actually onto the shafts, so nothing really moves apart. So back round on the other side then, we can carry on with the forward and reverse selector, and this is the tiny little rack that your handle interacts with to actuate it forwards and backwards. And after loosening all the grub screws in there, we can finally pull it out, and this is the shaft that's responsible for the forward and reverse, and this is kind of how it looks actually in there. After that, I'm just going to remove the rest of these grub screws, and I actually missed these the first time round when it was still on the lathe. And there's just a few more grub screws on the inside as well, including this one that the hand selector is connected to. So this shaft that I'm pulling out here is actually kind of like one of two free running shafts inside of this gearbox. Now they're not completely free running, they are obviously attached to the rest of it, but this is what the power gets transmitted through. So when you use the hand selector on the front to change between 1 to 2 gears, the power gets transmitted through that free running shaft to the rest of the gears in the gearbox. And these are the set of gears that actually get shifted left and right when you use the hand selectors on the front. And then on the other side you've got the high and the low, and this is the actual high and low gear. And then you've got the gear selector arm, and then you've got the actual gear that gets shifted forth and back to either the high or the low. And then you can see this is the spline shaft it runs along. Well, I don't know a lot about oil, but when it starts to look like glitter, I've got a feeling it's time for a bit of a change. So these are all the parts that we've taken out of that small little gearbox, and with that done, there's only really one thing left to do, and that is the headstock. So just before I jump actually into the headstock, I'm going to remove the rest of these gears on the outside. And this one was being a little bit stubborn. I didn't want to force it, so we'll just come back round to it later. But for now, I'm going to have a little go at this clutch. After we've carefully tapped out this pin, it gives us access to this housing, which we can just pull off. And inside of here, there's a small little angled 45-degree shoulder that gets squeezed up against these rollers that pushes the plates together on the inside of the clutch. So after removing both grub screws, we can just pull the clutch straight off. And on the side, it does say the Taylors. I'm assuming that's the company that made it. And on the top of the lathe, it says it's a multiple disc clutch. So to take this clutch apart, we have to hold back this little spring-loaded pin. And it tells you on the top of the lathe, where the small little diagram is, that this is the pin that you use to adjust the clutch through. So by indexing the pin either one hole to the left or to the right, you can increase or decrease the driving power of the clutch. And these are the clutch plates themselves. Now I have left these in the exact same order I took them out in, and I've gone over them a few times, and they don't seem to be too bad at all. They're very slightly worn, and there is a chip in one of them right at the top, I do believe. But except for that, they look to be in relatively good condition. The next thing that I want to do is remove the pulley system off the side, but after removing all the bolts I can't quite seem to get it off, so I'm going to remove the top off the headstock just so I can get a better angle to hit it at. And by the looks of it, it was just a hefty paint seal keeping it on there. Now we've got rid of this oiling system out the way, we can access the insides a bit easier, and I'm going to start on the clutch side again, and I'm going to remove this split pin that holds this much larger pin in place, that retains this bar into place. And this is the bar that's responsible for pulling that housing over the clutch mechanism. So the first gear that I'm going to remove from the inside of this headstock is going to be this drive gear, and this is where all the power from the motor gets into the headstock. And then on the front I'm going to remove this small little cap screw that gives me just enough room to slide in a tool to help me knock out this shaft. So with all that removed, we can go ahead and slip out this brake pad, and this is the braking system on this lathe. It's actually attached to the other side of the clutch mechanism. So as you disengage the clutch, it pushes the brake pad into the casting at the back of the lathe. And then on the flip side, as you engage the clutch, it slowly pulls the brake away. So it's impossible to have the brake and the clutch engaged at the same time. And simply put, they're both just connected to the same rod. And with that out, that's the rest of the clutch and the brake system removed. So this that we're looking at here is the gear selector system, and this selects between 3 gears using the handles on the side. There only looks to be about 1 grub screw holding this handle into place, and then there's just 1 more grub screw holding the gear onto the end of the shaft. Behind this little grub screw is a spring-loaded ball bearing that locks into one of 3 positions on that gear shifting rod. You can see the little holes in it, and this gives a little click when you change gear to tell the user that you're in the correct position. I believe this is called a shift fork, and you can see much like the apron, someone spent a bit of time with it as well. And this is what actually moves the gear to the left or to the right. So just before we start removing any more things from the inside of this headstock, I'm going to take the spindle out, and that's just going to give us a lot more room to work with. After removing the 4 bolts at the back for the cover and the small little grub screw for the locking nut, we can go ahead and undo it. And this is just one of 3 of this type of locking nut on this spindle. And round at the front side we've got 4 much larger 8mm bolts that hold the cover on, and this cover is just to protect the bearings from any kind of detritus or dirt from getting in there. So just before I can remove the spindle, I've got to remove the high and low selector, and this just comes out as one unit with just the one grub screw holding it in place. Then I'm going to go ahead and remove these 4 large bolts for the midpoint bearings, and they're also for this high and low gear as well. And I'm not too sure what torque spec those bolts were meant to be at, but they were extremely loose. And those bearing caps are also numbered, so I'll know which way around to put them back. And so with everything removed, it's time to hit out this spindle. We can't fully remove it just yet, but knocking it forward a few inches does reveal the second hidden spindle locking nut. And now hopefully we should be able to remove the full spindle. Grab this. So I'm not actually sure what you call these 2 plates, but from what I can see, they are solely responsible for transferring all of the power from the high and low gear to the spindle itself, since there aren't no keyways inside of this big gear, and all I can think of is maybe it's some kind of protection feature against sudden stops. Before I forget, I'm going to remove the rear spindle bearing, and this is about 10 cm in diameter, and it's a cylindrical roller pin bearing. After removing a very fiddly cotter pin, we can go ahead and remove the nut and then tap out the shaft. And this is a spline shaft with a set of 3 gears that run along it, and these are kind of like your shift gears that you control with the handles on the side that give you a set of 3 spindle speeds. And on this side is for your high and your low, and this is the shift bar that's coming out, and this is what interacts with your handle to actually move that gear left and right. And it's the same as the back side, but it's just a little bit smaller. So the next thing I want to take a look at on this lathe is the oil pumping system, but to get at it we have got to remove a fair few things. One of which is this shaft that I'm pulling out, which actually runs directly off of the spindle, extends out to the back of the headstock, and it's what drives your change gears along with your feeds gearbox. Another thing that we've got to remove is the rest of this high and low gear system, and this actually runs through 3 bushings because it's not only got to deal with rotation as it's driving the spindle, but it's also got to deal with linear movement too as you're changing gears. So round on the front side, just underneath where the chuck would be, there's 2 8mm bolts that hold on a cap to the end of one of the bushings, and then round at the back side we've got another cap that one of the external change gears ran on. So after that's been popped out, we can remove this sleeve off the end of the high and low gear shaft, and I think the reason they made it in so many pieces like this is because not only is it a bit easier to machine, but you can also just replace the single part instead of having to do the whole shaft, and as you can see that this one's been a little bit beat up over the time. So around on the front side then we can pull out this gigantic 7-inch bushing, and this is what allows this shaft to not only move linearly so it can change gears, but also so it can drive the spindle. So now that we've stripped down about 90% of the lathe, we can finally remove this oil pump. So after removing the little screw on the front, we can take off this mesh filter that's propped up by a small little brass spacer. On the top side we can pull out the plunger and the little spring behind it, and then I'll unscrew this copper exit pipe for the oil. Probably should have done that first. On the side there's a small little grub screw, and there's nothing behind there, that's just how they machined it. And finally, back on the top side we've got 2 cap screws that hold back 2 steel ball bearings, and these essentially just act as check valves to only allow flow in one direction. So now that the spindle's been removed, we can finally get to one of the hardest shafts to get to as of yet. It's mostly due to the fact that it's so close up to the casting on the right hand side that you can't really get a tool in there to tap it out properly. So right at the bottom, right underneath absolutely everything, we've got the last gear to remove, and this is split up into 2 pieces, and it's just the rest of the high and low gear set. So these are all the pieces that make up just that one shaft that sits right at the bottom of the headstock. This is one of the bushings that are definitely going to need replacing. So these 2 gears that I've got here actually slip inside of each other, and they are both marked with a small little line, so you have to get the orientation correct. So this is the main shaft that sits at the bottom, and it's got the second high and low gear cut directly onto it. And this is that large 7-inch bushing that just sits right underneath the chuck that goes over the end of the shaft. And then over on the other side we've got this steel sleeve that fits over perfectly, and then the bushing that goes around that. And you can see this is another one that's going to have to be replaced. So this is it, fully assembled, and this is how it would sit in the bottom of your headstock. And if I just move it forwards and backwards, you can see this is how it would look when you're changing gears. The whole shaft moves forwards and backwards. That's the reason you've got such a large bushing on the end. So the last thing that I want to do is have a look at the main headstock bearings, and this is the third and final spindle nut. So this is the spindle just on its own now, and it stands about 77 centimetres tall, and it's got a bore of about 36mm. So by the looks of it, there's 3 lots of bearings that sit in the headstock of this lathe, and the reason that is because they're using different bearings for the different forces involved. So all these bearings that I've got here are marked R&M, they're made in England, and they're all 130mm in diameter. So these 2 that I've got here are a set, and they're marked thrust, but they're angular contact bearings, and they sit back to back. So while these bearings can take both radial and axial forces, say like reducing the diameter of a piece of metal or facing, they can't really do either one extremely well, but they can do both kind of good, which is why they've paired it with this massive cylindrical roller pin bearing. Now this can't take any axial loads at all, but it is extremely good at taking high radial forces. And then finally, right at the bottom, we've just got the bearing cover, which has got a thread cut in it, and you can see that keeps all the dirt out. And this whole bearing stack sits about 3 inches high. So I think that just about wraps everything up in this video, and everything's stripped down and ready for the next one. And in the next video, we're going to be sanding up all the parts and repainting them. We're going to be making new bits and bobs, new bushings and shafts or whatever we need. I also want to go over a dial indicator with a lot of these parts to see how far out they are and see if there's something that we can actually do about it. And if there's a colour scheme anyone would like to see this thing in, leave a comment down below. I'm thinking grey, blue and red. So thank you for watching, and I'll see you in the next one.